Hey folks, so in this video I want to introduce the layered system architecture. So we just talked about organic system architecture. That wasn't too impressive, that was just make things work, right? There wasn't a specific order to it. Now we have a better idea. We want to make things layered, right? So we want to basically address that issue of maintenance, right? So our issues there, right, were maintenance, performance, right, security. How can we try to make things a little bit better? So this approach here is what we call a layered system. So basically I have this system over here, right? So we can look on the right hand side of the screen. I have basically these different layers, right? So 0, 1. The basic idea here is I want to separate out parts of my system. So things that have a specific, association, right? For example, with hardware, might all go in layer 1, right? Things that deal with, maybe, some abstraction layer above hardware would go over here, right? And over here, and over here. Some other this idea, and maybe I don't want to really look like a bullseye. There's this idea basically that you have abstraction going out, right? So this is low abstraction, high abstraction, right? So this is ultimately getting to user level over here versus this is obviously hardware over here. And the idea is we want to specifically separate out these different layers of concern, right? So I want to have, my hardware stuff here, right? My file management here, my GUI here, my user stuff over here, right? I want to have those things separate out specifically on layers, right? So user, so let's say, okay, so user, okay, we have hardware inside. We'll go like file management over here. We'll go graphics over here. I want to basically show that I have increasing levels of abstraction. So manipulating the file system is probably pretty low level versus doing some sort of a graphics display a little bit higher level, and then I finally get to user stuff. The idea is I separate out everything, right? So I have these different layers. Each layer has a specific responsibility, and anything that's to do with that responsibility is in that layer, right? So I don't have user programs also living on layer 1, right? Or file stuff living in the last layer, right? File layer n, right? I don't have that. Every layer has one specific responsibility, and all the stuff associated with that responsibility is in that layer, right? And those layers are mapped from the inside being lower abstraction to the outside being higher levels of abstraction, right? And ideally, right, and there's actually kind of two variants of layered, but ideally, basically every layer can only call the layer beneath it, right? So user can maybe only call this layer, right? This layer can only call this layer can only call this layer, right? The idea being is that you're separating out these different responsibilities and make it so that this program running at this particular layer can't tinker with stuff over here, right, at the hardware, right? We don't want to have that same issue that we had over in the organic design, right? We want to separate things out, and so generally we'll call that something like that maybe we would call we could call it maybe a pure design or an explicit design. Sometimes, right, they also allow basically downward motion, right? So anybody can go all the way down. Right, that's another thing you can do. This is maybe not so good though. I mean, it's more practical, but it's this is more secure. Right? If you only allow stuff to access what's directly beneath it. Okay, so this is our layered design. Right, this is a much better approach than we had before. So pros, right? It's obviously going to be more reliable. Right, so more reliable. I don't know. I don't think I spelled reliable right, but okay. No, there we go. There we go. Yay. More reliable, better to maintain. Say more reliable, right? Obviously, right, if I have this thing going on here where every layer isn't allowed to call every other layer, well, then it's more likely that I'm not going to call something that I shouldn't, right? If I'm already restricted in who I can talk to, I shouldn't be calling somebody I shouldn't. I should be running some system call that'll break everything in my system. Better to maintain. One thing is that we can kind of swap layers in and out, right? So I can actually, swap out this layer with a new layer n, and all the stuff inside stays the same, right? And this is actually very typical, right? So some operating systems, well, for example, they'll be built, right, so that, for example, the interface stuff is the highest layer, right? So I can take that operating system, I can port it to a new computer that uses a different interface, like for example from desktop to mobile, by just changing that one outside layer, right? Which is really nice, right? I'm able to replace things, right? Put in new things, everything else beneath it just all stays the same. I don't have to change anything. So it can be really nice for portability. Cons is it's slow, and I mean that both in speed and design, right? So it can be hard to design your system to take this layered approach, right? It can be hard to separate them out, right? Because the idea is that every layer has its own responsibilities. It can be hard to separate things out. Sometimes it's like, well, do I put something here? Do I put something there, right? Or you'll put something there and you'll be like, whoa, wait a minute, I can't just make a call down, I need to make a call up, right? And it's like, well, what do I do with this thing? So it can be hard to design these things, right? It can cost you time, it can be slow. The other thing, right, is speed. basically, if you go on, you can imagine you're doing a system call, right? A system call in layer n, right, in kind of a pure system, and let's say I'm in layer n, the topmost system thing, and I want to get the system time. I'll need to make calls all the way down, right? So I'll need to make a call to this next layer, next layer, next layer, right? So I need to make 3 nested calls all the way down. That's a lot of calls. That's going to slow me down because I need to make that call, that call, that call, that call, right? So performance won't be so good. All right. So this is what we have for layered systems, right? In the next video, we'll talk about another approach, which is going to be the microkernel approach. Microkernel approach will basically address this issue of speed that we talked about, where we have to go so many calls deep to actually get to where we want to go.